So after the ICSF received the SCSF capabilities, it will send the register request to start what's called by the authentication. And the target of the authentication is to make sure that this user is not a hacker. But that's not easy. So let's get to the concept here. If the UE is trying to authenticate on the network, then one can say simply why it's not easy. It can be done the same way we're trying to authenticate in everything, in the mail and the laptop. Just the user sends the username and the password, and in our case the password will be the IMSI, and for the username will be the IMSI, and the password will be what's called by the keys. So each user or each SIM card has a certain keys inside the network, and this is a confidential information. So we can say the user send the IMSI with the keys and the network see if that's right, then the user is authenticated, and if it's wrong, then no, it's not right, incorrect. So here the question that answers this: what if this network is not a real network, it's just a fake network pretending that to the user in order to tricks the UE to send the keys and then get the keys from it, and then tries to authenticate inside the real network with his identity, and now he's able to hack the user. Okay, so that cannot be done in this way. In order to prevent this from happening, a bidirectional authentication is done, which means that the network authenticates the user and the user authenticates the network. And that happens through this way: when the IMSI is sent by the UE checks the IMSI and knew that this user have the IMS services here, and gets the relevant keys for this user, and then generate what's called by random. The random is 128 bits that are randomly generated every new registration. So we have this random that is being generated, and we have the keys that are constant, and we have then calculation, and we have, before that, we have an algorithm to calculate what's called by the AUTN. But how it will be calculated? It will be calculated using these three parameters. The first one, the random, and the second one, the keys, with the algorithm to generate the AUTN. So if the user already knows the keys, what happens is the network will send the random and will send the algorithm to the user and tell him, look, I will send to you the generated AUTN. But why are you sending it to me? So now we are in the first phase. We are trying to authenticate the network. So here the network will be sent these parameters. We send the AUTN, the random, the algorithm. So the UE will confirm that this network is the real network. So the UE will get the random and will get the algorithm and will generate the AUTN. If the AUTN that's generated by the UE equal to the network generated AUTN, then the UE will complete the flow and send the register after that. But if not, then this network is not a real network, or maybe something is wrong, so I won't continue. So after the UE has authenticated the network by comparing the AUTN values, the network needs also to authenticate the UE, and that's done by the network actually calculates what's called by the expected response value and waiting for the UE to send it for the response, and if both values are equal, then the UE is authenticated in the network. So how this expected response or the response is calculated? We have the first thing here, the X out. The network actually makes XORing for the key with the random and then apply on it a Melnage algorithm, which is a 3GPP standard algorithm used to calculate what's called by the response the CK, the IK. So I'll be keeping also details for the managed algorithm, but it may take a long time for the managed algorithm, so I'll be keeping the details for it inside the slides. So that's it. That's the way the network has calculated the expected response, and the UE, we can see here sending the response with the CK, IK, which are the keys. Is this information is right? The CK and the IK, these are the keys. No, the key is already 128-bit we have mentioned. And this information, the key, cannot be sent alone. But the CK and the IK, we can see here, is also a managed algorithm applied on the X out we were just saying, which was XORing between the key and the random, and then a managed algorithm is applied, but with a different number of bits for the IK, and with a different calculation for the CK. We can see here F3. So yeah, that's it. Now let's go practical to understand it in seeing the example inside the trace.
Now, when the CSF receives this register, it will send the MAR request to the HSS. And actually, inside this MAR request, it will be asking the HSS for providing the SIP authentication data items. So yeah, the HSS will be replying back with this SIP authentication data items, which are these things, these parameters. So random, CK, and the IK. We can see here confidentiality key and integrity key, and the expected response present in the authorization. So the expected response, CK, IK, and the AUTN. Okay. So after that, after the HSS sent to the CSF, what does the CSF does? Will it send all this information to the UE? For sure, no. Actually, the authentication is now, till now, it's not yet performed to the UE, not even to the network, so it will just store inside itself the expected response. So as when the UE reply with the response, the challenge will occur at the SCSF side. So the 401 unauthorized response is being sent from the SCSF to ICSF. 401 unauthorized means like the user is still not authorized, so please challenge and send the response from your side, from the UE. So we can see here the parameters requested are less than here. And here the expected response that was present. Here, no, there is no expected response. And the same is sent to proxy CSF. So we can go also to the trace and see that from the ICSF to the proxy CSF. We will find here that the integrity key, the ciphering key, and the lance value are only the parameters being sent to the proxy CSF, and there is no expected response. Okay, so these are the parameters sent to the proxy CSF. Will the proxy CSF also will send all this information to the UE? The same answer will be no, because the UE till now also is not authenticated. So as we've mentioned in the theoretical slide, what will be sent only will be the authentication token and the random. Okay, so this is sent to the UE, so which is here the nonce value contain both concatenated with each other. Okay, so the ciphering key and the integrity key will remain in the proxy CSF, actually to make a tunnel like also after that between the UE and the proxy CSF. What does that mean? It means that at the beginning the UE was sending this register request to the proxy CSF. Anyone can hear it because actually it didn't contain any information, security information that we need to hide. So that's why it was containing only the IMSI. So it was okay, yeah, we sent it not encapsulated. But now, from here on, the UE will be sending the parameters like the CK and the IK. So first, we will enable the IPsec tunnel to make sure that this communication is ciphered. No one will be able to listen to it. So will be ciphered based on the CK and the IK. That's why the proxy CSF kept at its side. So the UE now will calculate the CK and the IK, and then we'll build the tunnel based on this, and the proxy CSF also have the CK and IK. So it will succeed in building this tunnel. So going here, what will be the difference between this register, the one first and the second ones? So now you will see here from the UE side towards the proxy CSF side, the protocol here is ESP, which is encapsulated security payload. So this is how encapsulated. Okay, so what is in, now we understood this. What was the information that should be present in this register that's from the UE to proxy CSF? So what we said before, that the response should be present because the challenge will occur here with the SCCF for the expected response. Okay, this is the first thing. Second thing, we knew already when this tunnel is enabled, then the UE already is already authenticated the network when it received the AUTN and the random. Okay, so the register is being sent from the UE to the proxy CSF, and afterwards the proxy will send also this register, which is now we can see here the register normally because the internal communication inside the network for sure will not be ciphered, but the communication outside the network must be ciphered. Okay, so the register between the proxy CSF to the ICSF, sending the register, and the user authorization request is being sent from the ICSF to the HSS. You may ask why just it didn't send it towards the SCSF directly. We already know because ICSF is a memoryless node. It does not store inside it anything, so it needs every time to turn back to the HSS. So the HSS this time will not be responding with capabilities. Instead, it will be responding with the registered SCSF already once. So it will give the SCSF address, and the ICSF will send the register request to the SCSF. And after that, here the challenging between the response and against the expected response. If it succeeded, then yeah, the authentication, we can say now, the authentication succeeded end to end. And after that, there will be the server assignment request. We cannot say that okay, so this is other part we'll be explaining, but for the authentication it is finalized after this challenging that occurs inside the node level. So yeah, this is authentication.